Hey guys, my name is Pradeep Gaddamidi. I'm a site reliability engineer at a startup called Radar. So every day brings in new challenges and victories. And here I'll share my adventure in deploying monitoring and logging platforms in the cloud without breaking the bank, as budget could be the constraint for many startups and not everyone can afford paid versions. So with that, I'm going to go over my agenda today. So I just did my introduction, and I'm gonna discuss about how to deploy the cost-effective monitoring and logging solutions, and then I'm gonna talk a little bit about the automation, and then how I did set up the SLA, SLO, SLI monitoring dashboards, and I'm gonna discuss my experience with incidents, in my organization, and then about the toil and time constraints and challenges and how I manage them. So let's dive into it. So the first thing, I wanted to discuss is the software, open source software and the infrastructure we choose for monitoring and logging infrastructure, or in fact, any other setup. So especially when your company or the startup which you're working for is budget constrained, obviously you want to choose, you're compelled to choose the open source version. So the main important, criteria we need to keep in mind is always research a lot before we actually choose this software, and also check mark all the requirements which your organization needed, and then choose the software. Uh, Let me take an example. So I did choose Elasticsearch for logging, and I did set up Elasticsearch on virtual machines, and everything went fine. There were some problems I encountered. So I cannot send Slack alerts from Elasticsearch because only paid version allows it. So since I was using open source, I can't send Slack alerts. So I have to, use a workaround for that. So I wrote a Python script, and then I used the Kibana server log, and then, filtered the alerts and used the Slack webhook, and then, sent it to the Slack channel. So it was kind of a backdoor way. So that's an example, but there could be something more important for your organization. So make sure like you check mark all those requirements before choosing any open source, and that way, and there is, and next, like choosing the right hardware. So there are certain ways where you can save some money by choosing the correct hardware. You have to identify the correct platform to run your application in, and also you have to compare the cost with different components available in the cloud. I mean to say different infrastructure available in the cloud, and decide based on the cost, and you have to weigh in advantages versus cost. When I did Elastic setup, I actually read through their documentation, and I found like not all the instances require the same amount of memory or CPU. So some instances consume less, some consume more. Like master nodes doesn't require a lot of resources. So I used the virtual machines which are of less queue for master nodes, whereas the data nodes, they are CPU intensive because there a lot of data comes in there, and then a lot of indexing and searching happens there. So I have chosen virtual machines with high CPU. So you have to weigh in the advantages and disadvantages, and which cost you more, and then choose accordingly and try to save costs there. That's all about how do you select software and hardware to save the costs. So let's talk about the automation. So far I've talked about logging, and I installed all of the monitoring components. I choose, again, for monitoring, I have chosen open source Grafana, Prometheus, Mimir, InfluxDB. So all those components, I installed it on a Kubernetes cluster. Either it could be monitoring or logging solutions. Everything I use Terraform. It's better to go with Terraform or Ansible. Ansible I use to configure the Elastic instances. So actually sometimes you feel like, okay, creating infrastructure manually, it's very easy, but in the long run, it's not a good practice, because you tend to forget the whole process, how to create, or if something happens, it's going to take time, and the documentation could be tedious. There are a lot of things. So it's better to go with any automation of any kind, Terraform, Ansible, or any other automation. And for my dashboards, for my Grafana dashboards, I I use CI/CD, and then I checked in the code in Git and then use CI/CD. That way, like if anyone messes with the Grafana dashboards, I can recreate them by running the CI/CD pipeline. And I used Helm charts to deploy, monitoring components into Kubernetes. So all this, using automation at first could take some time, or it could seem a little bit hard in the beginning, but in the long run, they are really useful, and that makes your system very resilient. All right. So yeah, on the same context, I would like to highlight, like in my Elasticsearch cluster, let's say I'm running out of, my data nodes are growing. There is a lot of logs coming in. All I have to do is like add in some entries, new nodes in the Terraform and run it. And that way it just creates those data nodes in just few minutes. So automation makes things really easy. Let me discuss a little bit about SLA, SLO, and SLI. I know these are very important parameters in DevOps world. Let me start with SLI. SLI is basically the metric that measures how well a service performs. Based on that metrics, you basically set up SLOs, and you come to some, you also set up SLAs with the customers. So how do you basically go with setting up SLIs? So, I did basically set up a lot of SLIs, but what I recommend is, start with the basic level. So if you have VMs, or if you're running some pipelines, data pipelines, so set up the basic alerts first instead of going with the fancy dashboards. That way, like you cover the basic stuff, There are a lot of SLIs, in fact, like you can set up availability, latency, error rate, throughput, saturation, traffic. They all help you decide on SLOs. But when you're starting up, right, in a startup, I think saturation is the important SLI we should first focus on. Saturation indicates how full a service is. It could be measured through various resource metrics such as CPU load, memory usage, or network bandwidth. Saturation helps predict and prevent potential performance degradations. This way, we make sure our system is well designed to support the load before we consider setting up other SLIs like error rate, availability, or throughput. All right, so let's move on to incidents. Incidents happens. There are basically in every in DevOps world, and then there are two types of incidents. There are some self-inflicted and some natural incidents. The reason I call self-inflicted incidents is because there could be some toil. Toil is basically the repetitive manual work that could be automated. And that could prevent an incident, occurrence of an incident, or setting up proper alerts for setting up proper alerts for the infrastructure could prevent some incidents. Let me take an example. So I had time constraints and I have a lot to do. So I missed setting up the alerts for disk on Elastic. And every time the disk filled on /temp disk, I manually went in and, cleaned it. I could have automated, but I have my own reasons for not doing that. Like I said, time constraint. So one day, like an incident happened and I had to manually go and fix the stuff. So this repetitive task, that's called toil. So we should address toil. So basically there are various ways. Maybe we could create a separate project, separate Jira tickets, and work as a team to address toil and set up proper alerts to prevent these self-inflicted events. And there are some natural incidents which actually occur. So when natural incidents occur, proper, root cause analysis and proper postmortems are really important. And moreover, we should play blameless game. So because blamelessness is very important to the success of a team or organization, so postmortems should be blameless. And for RCS, we generally follow a 5 why methods. You could search for number 5 why root cause analysis in Atlassian Jira, or you could Google. That basically applies to any scenarios. So basically, you ask the same question 5 times until you get to the bottom of the problem. So if the disk fails, you say why it failed, and then, okay, the disk was not scaled, then why it not scaled, then there was no time. Why there was no time for the DevOps, then it could be a, planning issue, then you will get to the bottom of the issue after you question 5 times. So you could follow such strategies to improve RCS and postmortems. Finally, let me discuss about toil, time constraints, and challenges. So workload is one important aspect in DevOps. So you might be already overburdened with a lot of vast amount of work to be accomplished in limited time frame. Commit only to what you can realistically handle and set clear expectations to avoid the stress of overcommitting. While it's not always possible not to overcommit, and if any urgent task requires you to implement a solution with minimum functionality, inform management about the limitations of the setup. This ensures they do not perceive it as a perfect and resilient system. So let me take an example. So I have been given like a week or two to set up like complete logging and monitoring system. So I had to take a hard decision and set up a system which was not resilient, which was a single point of failure. But I made it clear to the team and management like the system I'm going to design is could fail back at any time. So we were in an agreement. That way, like if some surprises come, I mean, when the system fails, there are no surprises to the management. So also like proper tracking where Jira tickets or whatever the ticketing system you use, right? That will help track the issues. That will help your track your work, and then that will showcase your work. That way, like management understands like what you're working on and what is the workload you could take more, and that actually organizes your work and reduces stress level. Yeah, proper tracking and documentation are also critical. So you basically document whatever you do, and you basically transition to other teammates. That way, like you don't get disturbed while you're on vacation, or some of the important aspects you should consider in the DevOps world. All right, so these are some of the learnings I learned in this startup. Like I know I'm still learning. We all are learning. So please let me know if you guys have any questions. Please feel free to send me an email, or please feel free to connect me on LinkedIn. All right, thank you very much for listening. You guys have a good day. Bye bye.